Hello and welcome to my channel. I'm the DIY and in this video I'm making a smart concrete lamp with an interesting twist. I was brainstorming for a month, thinking of an original unique build with the idea of making an art piece that is also functional for the space. Before I start from the beginning, I will show you a sneak peek of the finished lamp, and please don't forget to like and subscribe, it will help me a lot. I'm using a cheap concrete mix for this project. I will be also using a small chunks of styrofoam just to make sure I have enough of the concrete mix. For the mold I'm using a styrofoam sphere I got off Amazon, and for the mold core I'm using a wine bottle, which in the end I'm gonna use for the lamp itself. I left the concrete to cure for 2 days before removing it from the mold, and then with a fresh batch of concrete mix I patched few imperfections. I also made sure to wiggle and spin the wine bottle after 5-6 hours from the concrete pour to create a big enough gap so I can remove the wine bottle afterwards. I'm using the same wine bottle to make the glass cylinder for this project. I found that the easy way to scorch a bottle is to hold the glass cutter on something, in my case on a shaker, and slowly spin the bottle to scorch it. And then I'm using a candle to stress the scorch point to be able to crack and break it off, as you can see in this clip. I am building the lamp base using a 1 meter long wooden square stick with some fast current wood glue and some dowels. I didn't have any prepared plan or idea on how I wanted the base to look. I just sat down and planned as I go. But thankfully it turned out to be great, even though it took a whole evening to build. Now I'm measuring where to cut the threaded rod, and in the meantime I'm printing all of my 3D designs for the build. The rod is a hardened steel and it will be harder to cut with the jigsaw. And you also need to be careful of the kickbacks because of the threaded part. You just need to hold the jigsaw firmly and slowly go into the cut. In the meantime, I was building everything else. I was working on the code and predicting different scenarios from lighting delays to power loss and recovery. Also working on the hardware. I will just briefly show my kitchen setup where I was doing all of the testing for the code. I can tell you it was messy for a while. I have all of the final prints done, and what you see here are all of them that will be used in this project build. I will start sanding them to make sure they will fit snugly, and also spend a good amount of time sanding the cylinders, probably more than 2 hours. I purposely made the cylinders not to fit so I can control the very tight fit with sanding and smoothing. I did this mostly to make them silent and not to have any wobble when the lamp is rising up and lowering down. Before I start the glue up and the assembly, I need to drill a hole in the bottom part of the lamp for the power cord and the infrared sensor to pass. For the glue up of the bottom and the top piece, I'm taking real care the lamp is leveled before I start. And I'm using a good amount of silicone, so afterwards when I'm working the part in, I'm able to level it, and I'm constantly using the level to recheck to make sure it's still leveled. This will serve as a flat and leveled base where all of the parts will be placed on, and the lamp will be able to move up and down in a straight horizontal movement. To be able to fit everything inside the lamp, I needed to make my own board and fit everything in snugly. This will be the brains of the lamp, where I will be able to control it via Alexa, my Xiaomi smart system and my TV remote. The cool thing about this, I can make a schedule every day after the sunset for the lamp to open, and in a way it provides a cool effect, especially if you have guests at that time. The other reason for the compact board is for easier troubleshooting, and it will be easy for me to exchange any broken part or upgrade the code. I was planning to show the whole process, but due to my original video lasting more than 60 minutes, I decided to cut out the small details and focus on the important parts. This part in particular is very similar with my previous video about the smart blinds. The only difference is I'm using a small relay for the lights in this board comparing with the previous one. After the video you can go and check that video out, probably you're gonna find it as interesting as this one. So here I'm using a multimeter to check this relay, which pins are normally open and which pins are normally closed ones. I need to know this to be able to solder the proper pins. I'm also planning to post a short, extremely easy step-by-step DIY video on relays and how you can convert everything to be smart, from lights to devices or power cords, and you will be able to control it with Alexa. So don't forget to subscribe and click on the notification bell so you can stay up to date with my latest projects. I'm done with the soldering, and now comes the real test to make sure I didn't mess up. I will plug everything in and hope it will work, otherwise I will need to go back and find my soldering mistakes. Instead of using a power adapter to provide 12 volts to the board, I'm using a 12 volt power supply module that will be inside the lamp. I'm going for a clean setup and I will be able to plug the lamp into the power socket directly. You can say the same thing about the power adapter, but the big difference for me is I will not be able to hide the power brick easily, so I decided to go for the harder way. Before I continue with the soldering of the power supply module, I will use a multimeter to confirm I'm getting 12 volts as promised. I need to make sure I'm getting the correct voltage before I connect everything in and fry the board. Now we are ready to start with assembly. For the light I will be using a 5 volt wire LED strip with total of 200 diodes. I will start my way from the top and work down to the bottom, and make sure I will cover the visible rear of the lamp when the lamp is in an open state. This is a NEMA 17 geared stepper motor. I will use this one to drive the movement of the lamp. I will also be using a flexible coupling instead of a rigid one, as I don't want this part to be stiff, and it will enable the movement to be more flexible and won't break the glass cover by tilting the upper lamp. After months of planning and building, now it's time for the final assembly. This did took more time than it should, but mostly because I was taking the time to enjoy the last process of this build. I also had to carefully put everything inside in the tight space and taking care of the excess cables. I'm using a painter's tip on the brass nut to have better contact with the upper cylinder. This is mostly when the lamp is closing down and the nut will have enough of a grip to stick on the upper cylinder and not roll down on its own. I'm done with the assembly and the only thing left to do is put the upper part of the lamp, plug it in and enjoy the finished build. I will list most of the items I've used in this project if you're interested in the description. And if you enjoyed this build, please don't forget to like, share and subscribe. This will help me get more exposure as I'm new to this platform. I forgot to mention the lamp has a delay. When the lamp is on, the light will go first and after 5 seconds the lamp will start moving up. This is mostly for the dramatic effect. It's the same when the lamp is going down and after it reaches the closed position, the light will remain for 5 more seconds. If you made it to the end, thank you for watching and let me know if I've succeeded of making an art piece that is also functional, in this case a lamp. If you have any questions, also leave them in the comment section and I will give my best to answer them. I'm the DIY Ed and see you in the next one.